Welcome to the future of factory automation.
This program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM.
Okay, so let's talk about something that's been, well, buzzing around a bit in the automation space. Unit testing.
Ah, yes. Specifically for factory automation software, like PLC programs.
Exactly.
Yeah.
Coming from, a standard software background, you'd think, of course you need unit tests. But is it actually necessary on the factory floor? Or even practical?
That's the big question, isn't it? I was listening to this translated Japanese podcast, episode hashtag 26, I think it was called, Fire Archer Vake Western,
Right.
and they really dug into that. Is this essential practice from IT just as crucial, or maybe even feasible in the, let's say, unique world of FA?
Yeah, unique is a good word. Because we all agree testing is vital, right? Catching bugs early saves headaches.
Absolutely.
But then you think about PLCs talking to real machines, things happening in real time. Suddenly, it's not just if we should test, but how. And is the how even possible right now?
Precisely. Let's maybe unpack that a bit.
Good idea. So first things first, maybe a quick refresher on unit testing for anyone listening.
Sure. So basically, when you build software, it's like using building blocks, functions, methods, small pieces of code doing one specific job.
Okay.
Unit testing is where you grab one of those blocks completely on its own and you check. Does it do exactly what it's supposed to do? You test it in isolation.
Like checking each Lego brick is perfectly formed before building the whole castle. Makes sense.
Exactly that.
So the immediate thought is, well, we should do that for FA software too.
Mm.
Better code, fewer surprises.
That's the logical conclusion, yeah.
Yeah.
It follows all the best practices from decades of software development, fix the small stuff early.
But, and here's the big but, for factory automation.
Uh-huh. This is where it gets tricky. The practical side throws up some, well, significant roadblocks.
Roadblocks is right. The podcast mentioned a big one. Just the lack of good accessible environments to even do unit tests on PLC code.
Yeah, that's a huge factor. It's not like standard software where testing frameworks are common.
They mentioned TwinSat, I think.
They did, and said that even with some third-party tools potentially available for platforms like TwinSat, actually running effective unit tests is still seen as really difficult,
Yeah.
cumbersome.
And a major reason for that difficulty, I gathered, is the PLC's job itself.
Mm-hmm.
It's not just crunching numbers internally.
No, it's interacting with the real world constantly.
Reading sensors, telling motors what to do. How do you test that interaction without the actual hardware?
That's the core problem. A normal unit test needs inputs, and you check the outputs. But if the output is telling a physical valve to open, how do you verify that in a software-only test?
You can't just plug a virtual sensor into your test code easily.
Exactly. You need the device. Or,
Huh?
and this is where it gets interesting, a very, very good simulation of it.
Which leads us to digital twins. The podcast brought this up too, right? These virtual copies of machines or even whole lines.
Mm-hmm. That's seen as the potential key, the long-term solution.
So the idea is if you have a super accurate digital twin,
That mimics how the sensors behave, how the motors respond, all the physics.
then you could run your PLC code against that virtual environment for unit testing.
Theoretically, yes.
Yeah.
You could get meaningful feedback. But, and the podcast was clear on this, creating digital twins with that level of fidelity,
Yeah.
especially for diverse FA systems.
They're not quite there yet.
Not for widespread, easy unit testing. It's still a complex, often bespoke undertaking. It's not a standard tool you just deploy.
Okay, so given those challenges, where can unit testing work in FA today? The podcast mentioned some areas, didn't it?
It did. It seems most practical right now for testing individual functions or maybe custom function blocks that run entirely inside the IPC, the industrial TC.
Things that don't directly touch the outside world?
Exactly. Stuff that doesn't involve external I/O communication.
Can you give an example?
Sure. Imagine you wrote a little function block that just takes two numbers already in the PLC's memory and adds them together, or calculates an average from a set of internal data points.
Ah, okay. So it's purely internal logic.
Right. You can easily feed it test inputs, numbers, and check if the output, the sum or average, is correct, all within the software environment. No physical interaction needed for that specific test.
Simple math. basically.
Or maybe some data processing algorithm that works on data already collected.
What about servo motors? They mentioned something there too.
Yes, that was interesting. There seems to be a bit more possibility there.
Why is that?
Apparently, it's because many of the big PLC or IPC vendors provide their own simulators specifically for motion control.
Ah, so the manufacturers give you a virtual servo to play with.
Sort of, yeah. These tools let you test your motion commands, your trajectory planning code against a simulated motor, so you get some feedback without the real hardware.
But that's still limited, I guess.
Very much so. The crucial point they made was, okay, you can maybe test a single virtual servo, but testing how your whole production line works together with all the different sensors, conveyors, robots, specialized equipment.
It's a whole other ballgame.
Exactly. Because you don't have that comprehensive simulation environment for the entire system's interactions. Not readily available anyway.
Which brings up another interesting angle they explored. The scale of FA software versus, say, big IT projects.
Right. The argument was floated that maybe the need for super rigorous unit testing feels less pressing in some FA contexts because the code bases aren't always as vast.
How so?
Well, they suggested a typical FA project might rely heavily on, say, 30 or 40 core function blocks or routines.
Okay, compared to potentially thousands in a large web application or enterprise system.
Yeah, the sheer number of distinct units might be smaller in many FA scenarios.
And the thinking is if the code base is smaller, maybe manual testing is good enough.
That seems to be part of the perception, or perhaps justification, for why unit testing hasn't been as widely adopted. If you only have a few dozen core pieces, maybe you feel you can test them thoroughly by hand during commissioning.
I don't know. That feels a bit risky, especially long term.
I agree, and the podcast acknowledged that too. While it might seem manageable for a simple static system,
As soon as things get complex or you start making changes and updates over the years.
the risk of introducing bugs skyrockets. Relying solely on manual testing for complex, evolving systems becomes really problematic. Automated testing, including unit tests, becomes much more critical then.
So the scale argument only goes so far. Complexity and change over time really push the need for automation.
Definitely. Which loops us back again to the main bottleneck.
The simulation environments.
Yep. Without good ways to mimic the physical hardware and its interactions in software, widespread, effective unit testing across all of FA is still, well, a challenge.
But it wasn't all doom and gloom. They talked about software-defined automation, SDA.
Ah, yes, SDA. That was a really interesting part of this discussion, a potential pathway forward.
They mentioned a specific company offering a web platform aimed mainly at European manufacturers.
That's right. Siemens, Schneider Electric, Coatsys users primarily, though they mentioned others like Copas, Beckhoff too.
And this platform, it's more than just logging in remotely, right?
Oh yeah, much more. The vision is a central place to manage the whole automation project lifecycle.
Like what?
Things like automatic backups of your PLC code, which is huge, version control, basically Git for automation projects.
Wow, okay. That's a big deal in itself.
Huge. Plus, visualization of ladder logic, structured text, making the code easier to understand and manage remotely.
And then there was the AI part,
Yeah.
generative AI.
Yes. This was a recent development they highlighted, integrating generative AI so you could, for instance, give it a prompt.
And it could generate a basic project structure for you. For a specific PLC like Siemens or Codacy.
Exactly. Automating some of that initial setup work. It's pretty cutting-edge stuff for this field.
Now, how does this SDA connect back to our unit testing problem?
Well, the speculation, or maybe the hope expressed in the podcast, was that platforms like this, which have a deep understanding of the PLC structures, the project files, the code itself,
They might be better positioned to eventually help create or facilitate better testing and simulation tools.
precisely. If the platform knows your system inside and out, maybe it can help generate test cases or integrate with simulation tools more effectively down the line. It's a potential enabler.
Makes sense. But of course, there are challenges with SDA adoption too,
Naturally, they raise some very practical points.
like the ROI, right?
Right.
Especially for factories already up and running.
Exactly. How do you convince a plant manager to connect their operational systems to this new cloud platform? What's the clear, quantifiable financial benefit of, say, version control for a machine that's working fine today?
It's a tougher sell than fixing an immediate problem.
It can be. And then there's the ever-present cybersecurity concern.
Oh yeah. Connecting industrial controls to the internet always raises red flags. Big ones.
Absolutely. It needs very careful consideration and robust security. So SDA shows promise. It points to a future direction.
But it's not a guaranteed slam dunk yet. Business viability is still evolving.
Right. The podcast even mused about scenarios like one of the big players, Siemens or Schneider, maybe acquiring such a platform to integrate it into their own ecosystem.
Interesting. So wrapping things up, the overall picture is complex.
It is. Unit testing, standard practice, proven value in IT.
Yeah.
And FA, highly desirable, but currently difficult to implement broadly because of the hardware and interaction problem.
The lack of good, accessible simulation environments is the main stumbling block.
But advancements are happening, digital twins are evolving, and these new SDA platforms, they represent a potential future where managing and, importantly, testing automation software becomes more streamlined, more powerful.
We're learning from IT, but adapting it to the unique physical constraints of the factory floor.
That's a good way to put it. The trend is definitely towards more sophisticated testing. It just takes time and the right enabling technologies.
Hosting 200 daily episodes. Please follow and comment.
So here's something to think about. As factories get smarter, more connected, more complex, how sustainable is it not to have robust, automated testing like unit testing? At what point does the risk of failure in these intricate systems just become too high? And looking ahead, how exactly will things like AI and really mature digital twins reshape not just how we test, but how we ensure the fundamental safety and reliability of automated production?